Hey pre-calc, it's Mrs. Bergman. I'm making this video to show you how to do word problems involving eccentricity. You should have already watched the video that I sent to you to watch first to tell you what eccentricity is. This is a continuation of goal 3. So this is still goal 3 in your notes. You can continue it on. I believe yesterday I accidentally said it was goal 2, but it was actually goal 3, and we talked about that on Friday. So you should have that in your notes. Don't forget you have a quiz coming up tomorrow over this, so this could be one of the problems, so make sure you're paying good attention and ask any questions that you have in our discussion board. All right, here we go. So this is example 4 from your book. It says optics. The shape of an eye can be modeled by a prolate, or a 3-dimensional ellipse. The eccentricity of the center cross-section for an eye with normal vision is about 0.28. If a normal eye is about 25 millimeters deep, what is the approximate height of the eye? Okay, so we're going to use the eccentricity that they gave us, 0.28, to figure out the value of C. They told us that it's 25 millimeters deep, and this picture tells us that that must be the major axis since the other axis is 2B. So if the major axis is equal to 25 millimeters, that means that 2A equals 25 millimeters. Therefore, if you divide by 2 on both sides, you should find that A is equal to 12.5. Okay, now we want to figure out C. So 0.28 is the eccentricity. Remember, eccentricity is equal to C over A. So 0.28 is equal to C over 12.5. To solve this for C, we need to multiply by 12.5 on both sides. And you should get that C is equal to 3.5. Now that we have C, now we can figure out B to figure out the height of the eye. So we know that the relationship C squared equals A squared minus B squared is always true. Therefore, 3.5 squared must be equal to 12.5 squared minus B squared. Add B squared on both sides. Subtract 3.5 squared on both sides. Now I would just plug this into my calculator as the square root. Well, actually I would probably not do it under the square root. I would just plug in 12.5 squared minus 3.5 squared and see what that gives me. That gives me 144. So B must be the square root of 144. Which I know is equal to 12. So if the B value is 12, the height of the eye is 2B. It goes all the way from the co-vertex to the other co-vertex, which we know that length is equal to 2 times B. So the height of the eye is equal to 12 times 2, which is 24, and we need to make sure we use units for these since they are word problems. So the height of the eye is 24 millimeters. Okay, let's do one more. See if you can pause and try this problem on your own first. It says the eccentricity of a nearsighted eye is 0.39. If the depth of the eye is 25 millimeters, what is the height of the eye? I'm not sure if you guys know, but when you are nearsighted or farsighted, like when you don't have perfect vision, it changes your eye shape. So that changes whether your eye is circular or more of an ellipse. So if the eccentricity, it says in a normal eye, the eccentricity was 0.28. But in a nearsighted eye, the eccentricity is 0.39. So I want you to think about this and answer this question before you start the problem. Is a nearsighted eye more circular or more oval shaped than a regular eye? All right, think about it. 0.28 is less than 0.39. And remember in the video, it said that if the eccentricity is closer to 0, it means that the shape is more circular. So 0.28 is closer to 0 than 0.39. So a regular eye is more circular than a nearsighted eye. In other words, a nearsighted eye is more oval shaped than a regular eye. Okay, let's try the problem now. So the nearsighted eye eccentricity is 0.39. Remember, E equals C over A. If you haven't done so already, pause and make sure you know how to do this on your own. If you want to draw a sketch just like they had before, it's similar. We have 25 millimeters for the depth, 2B for the height. So again, A is equal to 12.5. So we have 0.39 equals C over 12.5. Let me get my calculator. 0.39 times 12.5 gives us 4.875 for C. Remember, C represents the distance from the center to a focus. But that's not what they're asking us for. They're asking us for the height of the eye. So that's asking us for 2 times the B value, because remember the B value is the center to the co-vertex. So if we want to go from the center to the co-vertex and the center to the other co-vertex, add that up, it'll get B plus B, that's altogether 2B. But we don't have the B value yet. We only have C and A. So we need to use this equation. C squared equals A squared minus B squared. So 4.875 squared equals 12.5 squared minus B squared. We're doing the same thing we did last time. Add B squared on both sides. Subtract 4.875 squared on both sides. Square root it to get B by itself. Now let's go ahead and plug this in. That gives us B is equal to 11.5 when you round it. Therefore, the height of the eye is equal to 2 times that. 2 times 11.5 is equal to 23, and our units are millimeters. Okay, let's say that they asked you to write an equation of this ellipse, because on your homework problems, I think both of them have a question that says write an equation for the ellipse if the origin is located at the center of the ellipse. So if it's at the center for the origin, that means H and K are 0 and 0. The origin is at 0, 0, and remember the center gives you H and K. So, it doesn't matter really if we put this horizontally or vertically, because either way it's going to be the same shape. And in a real world problem, it most likely doesn't matter if it's horizontal or vertical. Sometimes it does. For an eyeball like this one, they drew it as the major axis horizontally. So we'll just go ahead and use our horizontal equation. Remember that horizontal equation is x squared over a squared plus y squared over b squared equals 1. This is for when it's centered at the origin. I went ahead and made h and k both 0. So all I need to do is fill in the a value and the b value. So I get x squared over 12.5 squared plus y squared over 11.5 squared equals 1. To simplify, I need to use my calculator. So 12.5 squared, that simplifies to 156.25. 11.5 squared gives me 132.5 approximately, and it's equal to 1. So if on your homework problems, when they ask you for the equation of the ellipse, since it's centered at the origin, you can go ahead and plug in 0 for h and k to simplify it, and then all you need to do is fill in your a and b value, which you should already have. Okay, here's your homework for tonight. I'm going to set it up so that it's open for an online submission right away so that you don't have to wait until the morning. I think that's going to be a little too complicated. So I'll go ahead and open up an online submission. So get those problems done and send them in to me. Tomorrow morning at 8 a.m., make sure you are ready for your quiz. I will be sending you the problems. Make sure you know how to screen record so that you are prepared. You need to submit your problems by 3 p.m. tomorrow. I'll send them out at 8 a.m. and they are due by 3 p.m. for the quiz. This is your last quiz grade of quarter 3. So if you're struggling, I would really find somebody that can help you and FaceTime them and see what tips they can give you. Have a great rest of your day, guys. It's already Wednesday. It's halfway through the week. We can do this. This is our first week. I know it's tough, but we got this. Don't forget to like this video, comment, subscribe, Bye.